I couldn't find a slider online that really met my criteria for what I needed. I wanted something that was very customizable, portable, not too expensive, and something that I could fix if it broke, and use kind of mostly off-the-shelf parts. So when I started looking into really what parts I could use to build a slider, I found that the 3D printer sort of maker community already had figured out how to do linear slide, and so I really just built on that. I bought myself some 2040 aluminum extrusion that has a V groove, and I was able to go on AliExpress and buy gantries and wheels and pulleys and belts and all the things I needed at a really reasonable price. What you see here is the outcome of that, and I'm finding it's working quite well. The other positive thing that came about in my design is that I can really make it as long as I want. If I just buy more aluminum extrusion, I can extend it longer. I just need a longer belt, and really there's no limit to how long I can make it, within reason. And the gantry itself that slides back and forth is completely self-contained. The power, the controller, everything, the motor, everything that you need to make it work sits on a little car that slides along the rail. Again, if I decide to make it longer, I don't have to make extension wires or anything, or run a wire from one end to the other to move a motor. Everything just moves as one unit together. And then I can also take that unit off, put it in a bag or along my camera bag, and fold up the rail, put it in this tube that I bought at an art store, and that's my whole setup. I built this slider to just be used for time lapse, so it's designed to only move between the exposures. So this would mean that you could do nice long exposures for each photo. It'll move to the next position, then you could do another long exposure, so you don't have to worry about the motion blur of the actual movement of the camera. You can focus on the motion blur of whatever subject you're taking a picture of. So the way it works is we can have different movement profiles based on different mathematical curves. You can select the curve profile you want, movement profile, and what it does is it takes all the steps that the stepper motor would need to use throughout the entire movement and distribute those across the different exposures. So if a movement was like a parabola, it would start out really slow at the beginning and only have tiny, tiny little movements, and in the middle it would have the longest movements, and so it would appear like it's speeding up, and then at the end it would go slow again. So the triggering of the camera works by actually triggering an intermediate device called a Pluto trigger, which I bought online. I used the Pluto trigger mostly because I like the idea of having some isolation between my camera and the Raspberry Pi and all the electronics that I DIY'd. I'm just a little bit nervous plugging that setup directly into my camera, so having a middle device that would get fried is a lot. I'm more comfortable with that than the potential of frying my expensive full-frame camera. But the other reason is I have another camera that is converted for full spectrum, and it's an older Sony camera, and it can only be triggered by infrared, and the Pluto trigger can trigger it. So I can send a signal to the Pluto trigger into its auxiliary port, and then it will generate an infrared signal. Also, I have a move, shoot, move rotator. I can tilt the camera up and down, or I can rotate it right and left, depending on how I want to set it up. And I can set the direction of rotation and the number of degrees, and every time it takes a picture, between the pictures when the slider is moving, it will also rotate the camera. So I have that set up as well. Now, I am not actually a coder. I mostly use Chat GPT to troubleshoot some of my problems and help to write some of the code and some of the do some of the mathematics for the curves and things like that. So, you know, don't be too critical of the formatting of the code. I've just made it so it'll work, and I've shared it on GitHub if you want to download it and build this yourself. And I also will have all the hardware listed on GitHub as well. So go over to GitHub and check it out.